All right, I'm on page 235 and I switched apps because I think I'm gonna need more space for this. So try to get it on your notes. If it works, it works. If not, bust out some blank paper and take notes there. So the problem says, R is the region in the first quadrant bounded by the coordinate axes and the lines y equals 4 and x equals 10. So graph R, find its area, including generic units. So we're gonna say like units squared. So I need to graph this thing. So since I'm on a different app, I might as well like make use of it, right? So here and here, and then I got this is gonna be, let's say y equals 4, and let's say this is x equals 10. So we should label those. So this will be y equals 4, and this will be x equals 10, which also I guess I should do this, 10 and 4. All right, so this is the region. A really common thing to do is to shade in your region to indicate like that's the thing we're talking about. So then the area, this one's a layup. The area is going to be 4 times 10. I think I'd probably go 10 times 4, like more often than not. So 40, and then we don't have unit, like if it's feet and feet, it'd be feet squared, but here we're just going to say units squared. Some people might abbreviate that as just u squared, and you know, whatever you choose to do. All right, so that's our region that we're going to work with. And now what we want to do is we're going to do a couple things with it. So let's take a look at the next part. Suppose you take the region R that we just found, rotate it around the y-axis. We want to describe the three-dimensional solid this forms as completely as possible, find its volume, including units. All right, so I'm gonna re-sketch it. So this is kind of this is our 2D thing, right? And I'm going around the y-axis. It's gonna be like this. So I can tell already, because when I rotate a rectangle, I get a cylinder. So I'm gonna get a cylinder. This is 10, this is 4. So I'm gonna say that I get a cylinder, and then the radius is 10, the height is 4, so the volume is going to be pi r squared h. So the volume, that's a v. The volume is going to be 400 pi. So I think in this video I might end up using the calculator a couple times and like not showing you. What are the units on volume? So it's the radius is in feet, no, is in units. The radius is in units, the height is in units, so you do radius, radius, height, so units cubed. And I'm just gonna do u cubed. So that's it. Now, I don't think I've described this as completely as I possibly could. So what I wanna do is introduce you to the idea of creating the three-dimensional graph. So that's my z-axis. That's gonna be my x-axis. And that's going to be my y-axis, right? So I will label those so that it's a little easier to deal with, and I'll label them wrong. X, Y, and then Z. Okay, so this is a big deal. We got to take our rectangle that we're dealing with, right? So this rectangle, and we want to draw it in this plane type situation here in 3 dimensions. So what I'm going to do is I'm going to go like this, and then I'm going to go like, that's terrible. Hold on, let me start here and go like this, and then I will try to label this up, right? So I know that y is equal to 4, so that's 4, and then I know that x is 10. Okay, so what happens as I rotate around the y-axis? As I go around the y-axis, the rectangle that's in the xy plane is going to tilt up, and so z is not going to be 0 anymore. It's going to actually, you know, it's going to change. And what will happen is, as I rotate, eventually I'm going to end up in the yz plane. And when I get to the yz plane, I'm still going to have a rectangle. Y is still going to be 4, but Z will be 10 when I get there. So what I'm going to do is sketch that in. I should have gone up first. And there. Basically that. And then what I'll do is just kind of fill in the path. So I'm not super good at this, but you just kind of do this. So we're only drawing 1/4 of it. That's all we'll ever end up drawing for this. But I think that's like pretty good. So what I'm going to do is I now want to try to describe this, right? So I'm going to try to write parametric equations for this. So let's think, what is happening? I know that y is always going to be equal to, no, y is not going to always be equal to 4. I don't know anything right now. All right, hold on. So I want to slice this. So the way I'm going to slice it is, you know, if I take like a slice here and here, you can see that I'm always going to get these circular cross sections. Get up. Okay, something like that. And then I don't really know how to, let me see if I can do this. It's going to go like that. All right, I tried my best. That's my slice, right? So I know that y is going to be able to be every value between 0 and 4. As long as y stays between 0 and 4, I'm still going to be able to slice this thing. Think of a wheel of cheese, I think is the easiest way to think of this, right? So it's like, it's a giant wheel made of cheese. And I'm just going to slice off parts. And so y can go from 0 up to 4. And then let's see what's happening just in, so I'm going to focus in here on the XZ plane, because I think if I can describe that, then I can deal with this entirely. So I'm always thinking in slices. So this is X, and this is Z. And in the XZ plane, the cross sections that I'm getting are actually just circles. So let me, something like that. And they're circles that have, so you start to get the sense of why we don't usually do all of these problems in class. These are detailed problems. There's a lot to think about, but it's really good for your brain, like really good for your brain. So this circle has the equation x squared plus z squared equals 100. So I could parameterize that, right? I could say that x is 10 cosine theta and z is 10 sine theta, and that would give me parameters for that. I also know that y has to be able to go from 0 to 4. So let me like put that somewhere. 0 less than or equal to y less than or equal to 4. That like keeps me in the shape. So let's combine this, and we're going to write parametric equations for the surface. So this is new. We have not done this before. Here I go. All right, so I said x and z, I can parameterize just as a circle, right? So 10 cosine, I'm going to say t, and then 10 sine of t. And then I'm going to say that t is between 0 and 2 pi. All right, now what I want to deal with is y. So y can go from 0 to 4, but y is like not an angle, and it's not really related to x and z, bizarrely. So what I'm going to do instead is I'm going to say that y is equal to another parameter, and I'm going to use v. T and v are like the most common when you use two parameters, in my experience. Sometimes u and v, whatever. And I know that v has to be between 0 and 4. And if I make those things happen, I think that I will get this. So what I'm going to do, and then I will cut this and come back and do like more of this. This is only part B. I'm going to switch over to Geogebra, and I'm going to graph this, and you should definitely do this as well. So I'm going to switch to Geogebra. And Geogebra Classic, I definitely want 3D. So this is a new command. We've never used this command before, first time ever. And we are going to use the command surface. So surface is a lot like curve, but you need two parameters, and you need to like stipulate what each of them can do. So it's going to be surface. X is going to be 10 cosine of t. Y is equal to v, and z is going to be 10 sine of t. And then I'm going to say t can be between 0 and 2 pi. Then I'm going to say comma v can be between 0 and 4. And I can't see anything, but that is because I'm so far zoomed in. If you zoom out enough, look at this. And what's really interesting is if I tilt it, you can see that there's basically a rectangle here, right? And this rectangle goes 10 in the x direction, goes 4 in the y direction, and then we rotated that rectangle. And as we did that, we came up with this cylindrical thing. So this is not filled in. I tend to think that these are filled in. They're like surfaces and they have volume and whatever. I think of them as being filled in, but it doesn't really matter because we're describing the surface. But anyway, this is something we're going to play around with a lot. So you should definitely take a look at it, try it out. I hope you have found this helpful so far, and I will be back to do more of this problem in the next video.